Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-Scope. If you don't have a U-Scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. Hey, for listeners of the show, if you want a discount on Jarhead Diagnostic products, use discount code DIAGPODCAST. That's DIAGPODCAST, Diag Podcast, for 10% off purchases from jarheaddiag.com. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's episode. Thank you so much for joining me. Today on the show, I'm going to share a brief case study with you on a 2014 Subaru Forester that was setting a C1241 left rear wheel speed sensor circuit code. This is a used car lot that I do some work for, and they had already replaced the bearing and the sensor a couple times on the left rear of this vehicle, and they still get the same code. And so they wanted us to check it out, and so we get into it, and we end up finding the same thing, right? The code is in there. It's got the C1241 for a left rear wheel speed sensor circuit. Now, right off the bat, I'll just throw this out there for everybody. If you punch this code into Identifix, you'll see the fix for what's going on with this thing. And I didn't think that the fix was all that terribly interesting. It might be, but the way that the problem presented itself in this case is what I really found interesting. So I'll get there, and I just wanted to point that out, and that finding the problem on this, especially if you use a service like Identifix, probably not that hard. And if you didn't have Identifix, this would be a little bit more challenging. You probably could still get there. Again, the way that it presented itself was very strange, and I still have a few question marks, actually. I'm going to get a conclusion. But anyways, we do have this code indicating a circuit for left rear wheel speed sensor. Now, one of the things I like to do with wheel speed sensor circuit codes is I'll record the data. You know, I do a pre-scan for the vehicle, so I save all the information there. But I clear these codes out of the vehicle, and I want to see, do they come back immediately, right? Or after a key cycle. And sometimes you do have to cycle keys in vehicles in order to get the code to reset. So I'll always do that just to see, is there some sort of self-check it'll do on startup. But
I didn't even have to do it on this one. This one will set this code pretty much all the time. And you don't even have to start it. You don't even have to move it. It's going to set this circuit code for the left rear wheel speed sensor. And what that means to me about this vehicle is, or this circuit in particular, is that it is a circuit problem 100%. This is not a scenario where they put the pressed in wheel bearing in backwards. Obviously, you've seen that before. So the magnetic tone wheels facing out towards the wheel instead of in towards the sensor. I had a BMW recently where the guy was telling me, he's like, dude, I'm sure that I put it in the right way. I know how to do these. But we were looking at him like, there's no magnetic tone wheel. Well, it turned out the bearing that he bought, although it looked like the metal portion, right? If you look at one of those pressed in style wheel bearings and you actually take a look at both sides of it, you can usually tell visually that one side's the tone wheel and the other side isn't. And it looked like he had it in the right way, but there was no actual tone wheel installed in this bearing. Like, we put a magnet, we put metal shavings on it, and we're like, there's no magnetic force here at all. He just ended up getting either the wrong or a bad part. Anyways, that's not what I'm concerned about with this Subaru, because this codes immediately. This is a circuit problem. We're dealing with an electrical issue. All right, cool. Now, they've already replaced the sensor twice. Doesn't necessarily mean that it's good, but we'll take that into consideration as we jump into this. So if you pull up the rear carpet area, you can get to both of the connectors for the rear wheel speed sensors pretty easily on this thing. And these are the active style. I guess I still use the old passive active style terminology for wheel speed sensors. I don't know how accurate that is to say that, but not a variable reluctance style sensor, not a sensor that generates its own voltage. These are the style of sensor that are going to be a magnetoresistive, a digital output style sensor. And so they're going to receive a power feed of some sort from the ABS module, and then they're going to have a signal wire as well. I've seen that done differently on these, actually. I've seen it where there is a ground and then the signal is the power source. But I've seen it the other way too, where there's a straight power source and the signal's sent back on the return wire, if you will. Really what the ABS module is looking for on these active style or magnetoresistive style sensors is current. It's looking for changing current as the wheel's moving and that magnetic tone wheel's moving past the sensor. We can measure it in voltage, and that's the way I do it, because I don't even have a micro amp clamp. I've never tried one on an application like this, but you can see the waveform, the square wave from the wheel if the wheel's moving with voltage. Now, sometimes you really got to zoom in, because sometimes the fluctuation in voltage is actually pretty minimal. So if you're zoomed way out on the scope on your 20 volt scale, you might miss the actual pattern. If the wheel's moving, you kind of have to zoom in. And that's one thing about these active style wheel speed sensors is, again, the computer's looking at current for these sensors, where we as technicians, most of the time, if you're using a scope, and I should have mentioned we're looking at this with a scope, we're going to be looking at voltage, but the fluctuations can be small, so you might have to zoom in. I have a whole episode on magnetoresistive style sensors, so I could put that in the show links if anybody wants to check that out, get you more details on that. But anyways, we're in the back of this thing, and the nice part about wheel speed sensors is you have 3 known goods in most cases on vehicles, right? So if you're not entirely familiar with how the particular vehicle you're working on operates circuit-wise, well, you've got a good one right there that you can test. And you can even do some jumpering and figure out, is it the sensor, is it the circuit, what's going on? I like having known goods, and hey, you got 3 of them. So anyways, in the back there, you got access to both. And what I did was I tied in to the circuits on the left rear wheel speed sensor, which is the one in question, just to see what's going on. And on one side of it, I have power. And on the other side of it, I have roughly 0.3 of a volt, right? It's not ground. There is a little bit of a voltage. I ended up finding out that the power side is It's battery voltage and it's there all the time. And that's actually what I have on the good side, on the right rear side, same thing. And then on the return side, or you could say the ground side, like I said, about 0.3 of a volt. And that is also about the same voltage that I have on the other wheel speed sensor as well. So they look okay there. And so I wanted to actually move the vehicle and just see what was happening, because voltage wise, I was looking at both sides and I didn't see an issue. So I just plug into one of these and I just want to see, is the sensor outputting anything? Is it doing something? And I had to look on the side of the sensor that had the lower voltage, the 0.3, and I had to zoom way in on my U-scope, but I saw a pattern. I saw a square wave as the wheel moved, and I matched it up to the other side, and visually it looked the same. And this was actually, I looked at the scan tool at the same time as I was moving the vehicle, and it showed wheel speed on all four, including the left rear, which it was setting a circuit code for. I was like, huh, that's pretty strange there. I don't know exactly why it would be setting a circuit code if by my initial checks, everything seems to be working, but obviously it's upset about something. So we want to keep digging into it. So the next thing I'm going to do here, again, utilizing what I have on the vehicle and the easy access that I have to the things on the vehicle, is I'm going to use that right rear sensor, which I know is not setting a code in the ABS module, right? There's no code for the right rear sensor. I'm just going to unplug that and I'm going to jump it over to my left rear wheel speed sensor vehicle side, right? Harness side, ABS module side of the connector. So essentially what I'm doing is I'm feeding the right rear's sensor into the left rear circuit for the ABS module. And my goal is just to see, does that satisfy the ABS module, right? I unplugged the right, so I'm going to have a code for the right. But what happens when I plug that in? Because I know it's a good sensor. Electrically speaking, at least, it's not setting a code when I key this thing up. The left rear is. So I do this, cycle the key a few times, and I still get a code for the left rear. So based on the fact that they've replaced the sensor a couple times and the sensor that I know is good is not setting a circuit code, I can kind of move on from the sensor. But that was part of my testing, is I want to do that. I want to verify that this is a good part. It's working the way it's supposed to. And I actually did a little bit more confirmation here. I jumped the left rear to the right rear circuit, and there was no code for the right rear. So I know for sure that's a good sensor. Okay, so now we got to look at the circuit / module. So the ABS module is in the right front of the vehicle under the hood, and our sensor in question is on the left rear of the vehicle. And so we've got the whole length of the driver's side of the vehicle, and then under the dash, and then out through the firewall up to the ABS module as potential for circuit issues, right? And it still could be a module. I don't know yet, but obviously it's upset about something. So what do we do here in order to quickly assess where the problem is? So my thought here is to overlay a wire from the ABS module back to this wheel speed sensor and see if I can get the code to clear. And so essentially what I would be doing is ruling out any circuit issue with those wires anywhere by jumping it straight to the module. Now, I want to be real clear on what I did here at first, because, well, I'll explain as I go. What I did was I went to the ABS module. I found my 2 wires that go back to the left rear. I back probed at the module, and then I ran a wire from each back to the wheel speed sensor itself. And I plugged them into the left rear wheel speed sensor, and I had it unplugged from the harness. So if you can picture in your mind, my wheel speed sensor for the left rear is now, with good wiring, I know for sure, directly connected to the ABS module. It's back probed in there. And now I'm going to see if the code's set. The code still sets. And so my employee was actually with me at this one. We were checking this one out together. And I was thinking, I was like, well, is this a module issue? And he had actually suggested, I want to give credit to him, he's like, well, what if the rest of the circuit is what's causing the problem? I'm like, well, that's a really good point. We do need to rule that out before we call a module. So again, remember where I'm tied into the ABS module. I'm back probed into those circuits. So the actual full circuit is still connected to the ABS module. Now I've jumped all the way back to the sensor to try to eliminate issues, but I haven't eliminated the circuits itself from being connected to the monitoring circuitry within the ABS module. So what do I do here? We disconnected the connector. We were going to try to de-pin these connectors. Unfortunately, that was not an easy task, and we were afraid we were actually going to damage the ABS module connector. So I don't like to do this, but sometimes it's necessary in order to prove something out. I cut the wires about 3 inches down from the ABS connector. Now we're going to fix them when we're done, but I need to make a clarification between the ABS module being failed or the circuit causing this code to set. And the only way to do that is to remove that entire circuit or circuits from the ABS module and see what happens. So I do this. So we're cutting the wires, and now what I'm doing is I'm jumping that wheel speed sensor on the left rear directly to those 2 wires on the module, but I've eliminated all the other wiring for that circuit on the vehicle. Right, so we got a straight shot, nothing else involved. Cycle the key a few times after clearing the code. We do not get a code back. The module's now happy. So we know the sensor's good. We know the module does not have an issue. Our problem is in those wires. Okay, so we're thinking about this. We're like, okay, what could the potential be, right? Resistance in the wire, that's a possibility. We could also have some sort of short either between the 2 wires or to ground or to power, right? So what do we do to check for this? We decided to do a couple quick checks with the ohm meter at the back of the vehicle. We were back by the wheel speed sensor. We're like, let's just check them to each other. And picture in your head how we have this. The wheel speed sensor is disconnected. We're testing the harness side, and we've cut the wires at the ABS module. So those wires are no longer connected to the module. Right. So these 2 wires are just hanging out in the harness. When I go across the 2 of them at the wheel speed sensor connector, but the harness side, it should be OL. There shouldn't be any conductivity. And there isn't. I don't measure any conductivity. All right, cool. Well, let's check to ground. Let's see if they have any measurable resistance to ground. We should have OL again, right? And this is kind of going to like old school flowchart territory, but we have to identify where is the issue with these. And again, we can do a resistance value from one point to another, but that wasn't my thought, only because we overlaid the wire, right? Even though we still had those wires connected to the circuit, we still got the circuit code. When we overlaid the wire, we should have eliminated any resistance in that wiring, is my thought. So that's probably going to be my last check, is do, ohm check from end to end to see, or headlight bulb, through the wire to see if it can carry a load. I'm not worried about this wire carrying a major load, right? Think about electrical is doing work or sending information. This one's sending info. So it although resistance can definitely affect it, I'm not so concerned if it can light a headlight bulb through it. And anyways, my next check after ohming the wires to each other is I want to ohm check them to ground. Okay, so I take one end, I clip it to the body of the vehicle in the back, and I connect it to each wire. Now, this was interesting. On the meter, it said like negative 199 ohms. Okay, and again, my employee was on this. He saw that. He's like, well, that must mean there's voltage on there. And I was like, yeah, that definitely means there's something on there. If you ever ohm check something and you see a negative number, especially like 100 something, that's not a real value. As far as I'm aware, you can't go less than 0 ohms. You can't go negative. What that means is there's voltage on the circuit. There has to be. And if you understand how the ohm meter is actually working, it makes sense that it's going to throw it off, right? We always say turn the key off or disconnect the battery before you ohm check the CAN network, right? Because if there's voltage on the CAN network, you can't do an accurate measurement, because the meter itself is actually sending a small amount of voltage onto the circuit to do the measurement. That's how it's checking for resistance. So if there's already voltage there that the meter didn't send out, the meter's going to get very confused and throw you a wild number, which is what we're getting here. So Steve is right. There's definitely voltage on there. Here's the interesting thing. there was voltage on both sides, and we measured this. So we switched the multimeter over to a voltmeter. We're grounded. We're check it. We have 11 volts on one wire, and we have 6 volts on the other wire. And at times it was 3, but we measured 6 at times as well. So 6 and 11 volts on each wire. And this was the key off. We turned the key off, and we still have 11 volts and 6 volts on these wires that are completely disconnected from the wheel speed sensor and the module. They shouldn't be connected to anything. Okay, so where do we need to go with this? Now, this is where the Identifix article or post or hit or whatever comes into play. If we had actually punched this into Identifix, we would have been right to the failed component immediately, because it was the top hit and a bunch of fixes for this exact code on this exact connector. So B99 in the left front kick panel is a point where I guess these Foresters build up a lot of corrosion, and the wheel speed sensors are going to pass through this connector. And this is an issue. It causes a problem. Okay, so we get down there. Now, we did not find any corrosion. What we did find was somebody else had already been into this thing. And we could actually tell signs that someone had been digging around on this vehicle with this circuit elsewhere back by the ABS module. You could just tell that it had been disturbed, and we weren't sure if it was just from them replacing the sensor or if someone else had been into this. But once we were at the connector, that B99, the left front kick panel, someone had actually cut and soldered in new wires and pins into this connector, which we thought was odd. So we took this apart, we unplugged it, and we looked, and we're looking for corrosion to see, is there voltage bleeding over into this connector somehow? Now, while we don't see visible corrosion in this connector, you could tell at one point there was corrosion in this connector. And what I mean by that is if you look at the back of the pins where you see the metal crimp that goes from the pin to the wire itself, you can tell that the metal has been like discolored a little bit, like there was corrosion in this connector. But we're looking on the pins and we're looking for water, a corrosion path, something from the neighboring pins to this wheel speed sensor that it's going to allow voltage to cross over into that circuit, because it definitely is. And this is the only connector that's in line. I should have mentioned that. If you look at the wiring diagram for the left rear wheel speed sensor, this is the only connector between the ABS module and the sensor itself. And there's nothing visible on this connector. If you just look at this thing, besides the fact, like I said, you could tell like there might have been corrosion at one point. It looked like somebody cleaned it up pretty good. All the metal is shiny on the pins for the female side of, I'm looking at the female side of this connector specifically, and I don't see a buildup of corrosion. I don't see moisture in this connector at all. So we started to do some measuring with the meter just to see, is this our point of problem? Is the voltage bleed over happening? Now, what we ended up finding out is the neighboring pins to these two wheel speed sensor circuits did have the 11 to 10 volts and then the 6 to 3 volts, right? One wire had one, the other had the other voltage, and they were neighboring the pins that we measured the voltage on for the wheel speed sensor. So we're like, okay, well, this is definitely where the voltage is crossing over, but how, right? And so what I did was I depinned one of these connectors. I pulled the connector or the pin out of the connector for the wheel speed sensor, and the voltage went away on the wheel speed sensor circuit, which is what we're hoping for. That's our goal. Right? We don't want this excess voltage on the circuit, because that's what the module's upset about. Now, whether it's measuring that excess voltage when the key is on, or maybe it's measuring it when the key is not in the on position, I think there was a self-check for this circuit when you keyed it up, and maybe that's when it saw voltage it didn't want to see. I don't know exactly how the module determined that, hey, this isn't right, but it definitely did. It saw voltage at a time or at a level that it didn't want to. The strange thing was I didn't really notice it when I was just scoping the circuit with my U-scope, but I don't know that I was paying close enough attention to the levels. Anyways, I've depinned this connector, and now my voltage drops away. So I know it's coming from in this connector. Now here's the very, very strange thing, and this is kind of why I even wanted to bring it up on the podcast, was I'm looking for a corrosion path or a method for the electricity to cross from one pin to the other within this connector. Because I just want to like show the guy like, yeah, here's your problem, right? I don't see anything in this connector. Again, it's a small connector. It's kind of dark in the shop, but I'm using a flashlight. I don't see moisture buildup. I don't see corrosion. It's a white plastic connector, and maybe it's disguised, but I'm like, I don't see anything in this hole that I've pulled this wire out. I put the wire back in. I've got the voltage back on that wire again. So I pull the pin out of this connector and I go in with my voltmeter lead, and I have a picture of this, and my employee was standing right there. So I'm like, you're seeing the same thing I'm seeing. I'm touching the plastic inside of the cavity where there is no metal pin. And there's a metal pin adjacent with the voltage that's coming over. With my meter, I'm measuring voltage on the plastic of this connector. And again, I had to like do it a couple times, and I poked around in a couple different spots in there, and I showed Steve, I'm like, you seen what I'm seeing, right? I'm measuring in the picture, it's about 4 volts on the plastic of the connector. And again, I'm like, is there corrosion in there? I'm just not seeing. I couldn't see it. I'm not saying there isn't, because I understand plastic doesn't conduct electricity, which is why it was so strange and why I'm even talking about it. And so we ended up showing the guy who runs the shop, and he wasn't as interested in it as we were, but we were both just kind of like, this is very strange. And it was on both pins too, right? There was a bleed over of 10 on one and 6 on the other. So it's not like the whole connector was conductive or something like that, but somehow or another, there was a conductive path from one pin to another. Now, I told this guy, because he's going to get a different connector for it, I was like, you could bypass this connector for the wheel speed if you wanted to, but I would really replace the whole thing, because something very strange is happening here. Maybe there's a pathway I'm just not seeing. But what I told him was like, I want this connector when you're done, because I'd like to put it on a bench with some good lighting and take it apart and see what am I missing, right? Is there actual like corrosion in there that is colored in a way that I'm not visibly seeing it? Or is there something else, strange, like some sort of strange capacitive thing going on to the plastic? And I know that's probably stretching it, but I'll show you the picture. I'll put it in the Facebook group. I'm touching the plastic with the meter lead, and I'm measuring voltage, which is pretty well. And here's the other thing. It's not like, I've talked about this on the show before, right? You can take a voltmeter, take the black lead, put it on the negative post of the battery, hold the red lead in your right hand, touch the positive post of the battery with your left hand, and you'll measure voltage on the meter, right? So you can measure voltage through pretty high resistance, but not plastic. At least not usually. And the other thing was, this was measured all the way on a circuit from the left rear of the vehicle up to the right front corner of the vehicle in the module. So it's not like it was just a minuscule amount of voltage that would pull down to zero real easily. Like, this was a measurable voltage. The ABS module saw it. We saw it with the scope and the meter. We saw it with the meter. Very, very strange. So that was kind of just really the point of why I want to talk about it, is because I've never been able to measure voltage on the plastic of an electrical connector before. And I'm really curious if anybody out there has had something like that happen, or am I just very blatantly missing something in this connector? But again, I'll put the picture up. It's not the greatest picture in the world, but it shows what I'm doing to this connector, and it shows the voltage being measured. So I'm not making it up. And I want to get this connector. I want to take it apart, and I'll put up a video or a picture or something if I get it. But I just found that part of it really interesting. So I want to share it with everybody. So that's it for this case study. Thank you so much for listening. I really appreciate it. And I am jealous of all you out there at ASTE this weekend. I hope you have a great time and learn a whole bunch. I wasn't able to make it this year just because I had too much going on. The prior weekend, I was out of town. I'm leaving town again in a couple of weeks, and I couldn't just fit it all in. So anyways, Thanks again. And with that, let's get out there, start fixing the world one car at a time.